Welcome back. Tonight we are going to talk about how to graph quantitative variables using histograms. Histograms are a type of graph that we're going to be using quite frequently in this class, so this is going to be an important section for y'all to pay attention to. What I'm going to show you right now is how to graph a histogram by hand, and then tomorrow during class I'll actually show you how to graph or how to create histograms using your graphing calculator. So please make sure that you bring your calculator with you to class so you can follow along on your own. So we're going to start off with this data. This gives you, as you can see, the percent of foreign-born residents per state. So we've got all 50 states listed and then the percents of their residents who are from other countries. And we are going to create a histogram using this data. So first of all, let's talk about the steps that are involved in creating a histogram. The first thing you need to do is to divide your data into classes, sometimes we call them bins instead, of equal width. So let's take a look at the data again, and I'll explain what I mean by that. So as you can see, we have a pretty wide range of percents that we're dealing with. What's the smallest? It looks like West Virginia has a pretty small percent of foreign-born residents with only 1.2%. And then we've got California with a whopping 27.2% of residents who are foreign-born. So we need to take what's called the range of our data into consideration. We start at a low value of 1.2. We go all the way up to 27.2. So we need to use that to consider what would be a reasonable way to split up this data into the bins. Since we're basically going from 0% up to about 30%, in my opinion, if we only did bins of width 10, that would only give us 3 bins. We probably wouldn't get we wouldn't get very much information about the distribution of our data. So we need to make our bins a little bit smaller, and I'm going to choose to put our data into bins of width 5 instead. So that means, for instance, anything between 0% and less than 5% will go in the first bin. So West Virginia will go in that first bin, Wyoming, Wisconsin, Vermont, Tennessee, South Dakota, South Carolina, etc. There are several states that'll fall into that first bin. And then we'll move up another bin. And that second bin will have states whose percents are between 5 and then just below 10. And then we'll move on from that on up until we account for all the states, up and including California with its 27.2% of residents. So that's our first step. Let's go ahead and fill in this frequency table. Sorry about that. We are going to do step number 2, actually. We're going to find the count, that's the frequency, of the number of individuals in each class. So that's basically what I was doing before. So I just need to go back to our data, and I'm going to count the number of states that fall into our first bin, which again is from 0 up to, but not including, 5%. And then I will count to see how many states fall into the second bin, which is 5% up to but not including 10%. So give me just a moment and I'll get those counts taken care of and we'll get right back to it. Okay, so I've gone through our data and I have counted up all of the states that fall into our various categories. Did it somewhat systematically and tried to color code it. So it turns out that there are 20 states that fall into the first bin, 13 into the second, and so on. And as we saw earlier, California was the largest, the state with the largest percentage of foreign-born residents, and there's only California in that last and largest bin. So if we count up all the counts, we should have all 50 states accounted for. So this is how we will start to create a histogram using this idea of a frequency table. Again, it's called a frequency table because we're dealing with the counts here in each of our bins. So that was step 2. Step 3 in the process of creating a histogram is to set up your axes label and scale them, and then we'll draw in the histogram itself. So here we go. I've already set up the axes for us. Notice that I've got a few different titles and labels on here. Whenever you're creating a chart, it's going to be very important that you label it properly so that anyone trying to read the chart and get some information from it knows what you're talking about. So I've got an overall title up here at the top, and then I also have labels on both of the axes. On the vertical axis over here on the left, I've written that this represents the number of states, and that's because we're doing a frequency histogram. We're talking about the counts, the number of times states show up in the different bins. And then down here on our horizontal axis, we have our various bins, and the title is the percent of foreign-born residents. So now what we're going to do is go back to our frequency table and use the counts that we came up with to figure out how high the columns in our histogram should be. So as we've already said, the count in our first bin is the largest. We've got 20 states that fall between 0 and 5%. So we're just going to go back over to our axes. We'll do this in red. And so from 0 up to 5, up to 5%, we've got 20 states that fall into that bin. So I'm just going to create a column right here. And then our next bin ranges from 5 to 10, and there are 13 states in there. So 13's about here, and that goes over another 5 units. We're just going to keep repeating this process. So next in the bin from 10 to 15, we've got 9 states. And then from 15 to 20, we've got 5 states. And then from 20 to 25, we've got 2 states. And then we already know that in our last bin, 25 to 30, we just have 1 state. So there we go. That's our histogram, again showing the frequency of the distribution of foreign-born residents by state. Now, if you happen to notice back here on the step slide, in step number 2, I said you could also find the percent, otherwise known as the relative frequency of the individuals in each class. So this is really just building on what we did, but instead of representing the counts like we did here in this column, we're going to represent the percentage of states that each bin represents. So we're just going to create a relative frequency table. Notice over here on the left, our classes remain exactly the same. We're still splitting up with 0 to less than 5% of residents, 5 to less than 10%, etc. We haven't changed that at all. It's just what shows up in this percent column that's going to change slightly. Well, if we're dealing with data that's about the 50 states, it's pretty easy to translate the count into a percentage. For instance, in this first bin, if our count is 20, well, 20 states out of 50, that's 40%. So in our relative frequency table, in bin 1, we've got 40% of our data there. In bin 2, we have 13 states, which translates into 26%. And then in bin 3, we've got 9 states, so that's 18%. And then in the last 3 bins, we'll have 10%, 4%, and 2%. And then, of course, if you add all those percentages up, you sure had better get 100%, or something has gone terribly wrong. Now, so we can use this relative frequency table to create a histogram for ourselves if we would rather use the relative frequencies instead of the just plain old frequencies like we did on the last histogram. Notice this looks almost exactly identical to the histogram that was already created. The only difference is over here on the left, instead of having the number of states on the vertical axis, we just have the percentage of states. So I'm going to go ahead and draw in our columns for the histogram. We know that the first bin represents 40% of our data. We know that our second bin represents 26% of our data. We know that our third bin is 18%. Our fourth bin is 10%. Then we've got 4% and 1%. Now you're probably thinking, well, why in the world did we do that when this histogram, where we use the relative frequencies, looks exactly the same as the histogram where we used just the plain old frequencies? And that's a completely valid question. In this case, just because all we're doing is taking this one set of data and looking at its distribution, it doesn't make any difference which version of the histogram you look at. But the reason that a histogram that uses a relative frequency can be helpful is that if you're trying to compare several sets of data, maybe, let's say, you're trying to look at, how about this, the ethnic backgrounds of the student population at various independent schools around Louisville. Well, if that was the case, you wouldn't want to base a histogram on the counts because you don't necessarily have the same number of students at all of the schools. Obviously, we know that St. Francis is a pretty small school, so we wouldn't want just our overall count to be compared to a much larger school because that might not give you a good idea of what the data actually is indicating. Instead, we would want to use a relative frequency histogram where the percentage of our students of various ethnic backgrounds, I suppose, would be shown. Now, there are a few other things that we need to talk about in relation to histograms. One thing is that histograms look a bit like bar graphs, which is what you learned about last night. Because with histograms and bar graphs, we just have these columns that indicate how many things go into a certain category. Obviously, though, there are some differences between histograms and bar graphs. First of all, the major difference is that a bar graph is only going to be used to represent categorical data, whereas histograms are only going to be used to represent quantitative data. So that's a pretty important distinction to be aware of. You should also notice that when you have a bar graph, I'll just draw a really rough sketch of one. Maybe it's something like this. The columns are separated so that you can see a separation between the different categories that are being described. That's not true of a histogram, though, because all of the bins, there shouldn't be any gaps between them, like we saw on our example. So the vertical columns on a histogram should all line up with no spaces in between. And for now, I think that's all that we need to talk about involving histograms. If you have any questions, please let me know. And also a reminder that tomorrow in class we are going to talk about how to create a histogram using your calculator. So please make sure you bring it with you when you come to class.